Hello, Algebra 2 students. Today we're going to look at our first member of the library of functions and how to manipulate or transform it. In other words, how to change it into different versions of an original self. Okay? So first, I think we'd better identify what that original self looks like that we're going to be working with throughout today's lesson. So the function we've been kind of exploring in one dimension so far has been absolute value, right? So now we're going to look at it in two dimensions. So first, let's look at what it looks like in two-dimensional space. We'll go from there and start transforming it. When you start this lesson, you should have your calculator in front of you and also the transformation guide that I've made. Okay, so first we need to figure out what kind of shape absolute value has. So let's think about something really simple as a motivator. Y equals x. Can we graph the line y equals x? I hope so. It's a line we should all have memorized pretty much. Its intercept, y-intercept is what? 0, because there's plus 0 here, right? So it goes through the origin. Its slope is? The slope is the number attached to x, correct? It's the coefficient attached to x. So what's attached to x here? 1. If you write that as a rise over a run, it's 1 over 1, right? So you go up 1 over 1. There is the line y equals x. It's the diagonal 45-degree line. There's 45 degrees here and 45 degrees here that splits the coordinate plane. Something we should all know from memory without even having to think about it. So if you don't know that, get it in your brain right now. Okay? So that's y equals plain old x. I want to graph y equals the absolute value of x. So in the last lesson, we used one way to think about absolute value. What was that way that we used in one-dimensional space? Yeah, we used inequalities, but what was the idea of absolute value that we used? You guys help me? Yeah, Wiley? Yeah, how far stuff is away, especially from 0. That's what absolute value meant. Very good, that's it. What was the simpler way to think about absolute value that we know? What does it do to things? Makes them positive. So are there some things on this graph that are going to get changed because of the making it positive aspect of absolute value? I think so. This thing? No. This thing? No, both the x and y coordinate are positive there, right? How about this thing? Y coordinate here is... The y coordinate here is negative, correct? So it's going to make that coordinate positive. So this guy's going to get flipped up here. This guy's going to get flipped up here. Anything that has a y coordinate that's negative is going to get flipped up here. That's the absolute value graph shape that you need to memorize. Remember how we left a couple pages in the front of our notes? If you didn't, use the back of your notes. But you should say library of function. This is your first graph you need to have memorized this year. It's a very simple graph to memorize because what nice, neat shape does it have? A V, right? So I'm going to say this has a V shape. That's our first graph. We need to have the picture memorized for the year. I think there's 20. It's going to be pretty easy to memorize all 20. We have a whole year to do it, right? Okay. So how can you write that? There's a special way to write that. I'm going to introduce you to something we're going to study in depth during the third quarter. This is called the piecewise function because really the V is kind of made of two different pieces. What is each piece? What kind of shape? A line, right? So the first piece is the regular old y equals x, right? That's this piece. The other piece is a different line. What line is this in mx plus b? Intercept's still 0. What's this one's slope? Instead of up 1 over 1, it's down 1 over 1. So negative 1x. Okay? Absolute value is x if x is greater than or equal to 0. And it's negative x if x is less than 0. Really, it doesn't matter where you put this equals because in this case they go through the exact same point on the edge. So that's your first piecewise function. We won't be using that for a while, but just so you guys have some background. I exposed you to it once. Might be useful on a problem. You never know. I think there's one on your side. So, all right. The main point of today's lesson, though, is to think about how to change that around, how to make it into new versions. All right? So on your sheet, Got that transformation sheet in front of you. I want you to have a look at what kinds of things we can do to this. Pretty much covers all the kinds of things we're going to do all year. You can shift stuff up and down. You can shift them left and right. You can flip them over this way or this way. You can stretch them vertically. You can stretch them horizontally. You can compress them horizontally. These are all the different varieties of transformations. So we're going to start with the easy ones and build up. I think there's only one that can be kind of dicey sometimes. And I'm not really going to test you on that during our first chapter. So let's have a look. So first I want to transform f of x equals the absolute value, so plain old that. And I want to take it down 3. We can easily picture what that's going to look like, right? So drawing this is super simple. So you say, okay, scoot every point down 3. So the vertex goes 1, 2, 3. Up 1 over 1 is going to go right there, right? There we go. That's g of x equals absolute value of x minus 3. I think that's really intuitive. There's nothing sneaky about it in any way, shape, or form. If you follow the transformation sheet, though, it tells you exactly what to do. Have a look at where it says vertical shift. Have a look in the vertical shift at where it says down. Doesn't it say g of x equals that plus or minus k, and our k is, of course, 3? Nothing sneaky has happened at all, right? So super simple to move stuff up and down. I hope. All right, the second example says transform f of x equals the regular absolute value again. Make a new function with it that goes right by 8. So I want you guys to tell me what to do, and then we're going to try to make sense of it. So look at your sheet. If you're watching the video, you can pause it. Look at your sheet, find the right or left spot, and tell me what to write. So what am I going to write? I'm going to write g of x equals what? Have a look. It tells you everything as a cheat sheet. Give them a sec, Wiley, and then I'll let you answer. Nice. Heck yeah. You guys think you know what to do? Now, I want you to tell me, is this going to be an inside thing we got to put that 8, or we're going to put that 8 inside the absolute value or outside?
Inside.
Inside. Cool. So leave some space. I'll put an x, right? And inside, am I going to go plus or minus 8?
Plus.
The majority said minus. Did you look at your sheet, Grant?
I believe so.
No, I don't think you did. So it says right is minus.
Oops.
It's cool. Just saying. You're being too nonchalant.
I thought we were going left.
Minus is right. That's something you need to get in your head right now. I'm going to try to bring this all together on the next example. So that's what it is. Now, when you look at this, from now on, you should just know, oh, that's absolute value shaped, right 8. Boom. It's pretty easy to draw that, right? You can just go, take the vertex, go 1, 2, 3, 4, 5, 6, 7, 8. Let's see, Katie, can you tell me where would this hit up here? I didn't draw a very specific graph, but I should know where it hits up there. Where's it going to hit? On the y-axis, do you know?
Can I draw first?
Yeah. Anybody else know? It's going to hit up at 8, right? Because the slope is up 1 over 1, up 1 over 1. Do it 8 times and you're going to get up there to 8. It's because we haven't stretched or dilated any of these out yet. We'll do that in a second. Okay, so let's do one that kind of combines those two things. I'll get this out of my way. And let's combine both things now, all right? So this one says translate. Again, we're going back to the very original V shape, and it says translate it to have a new vertex. So I think it'd be best to draw this one first and then try to write down its function expression. You need to be able to do both. What do you guys think is more important, the drawing or coming up with the function expression? The function expression is really where it's at, because drawing this is like, okay, move a V shape, right? Like, that's super simple. So the function expression is really what we're focused on the most. All right, so I need to be in the fourth quadrant. Fourth quadrant? Which quadrant is this vertex in? 1, 2, 3, right? So I'm going to go 1, 2, 3, 4 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Need to keep going. 11, 12, 13, 14, 15. Okay, so there's my vertex. Did I say do any other transformations with it? Did I say like reflect it or flip it or stretch it out or anything like that? No. You're just supposed to have that same V shape, right? So here's the V shape. I wasn't very careful about how I wrote that. If I was careful, I'd have to go up 1 over 1, up 1 over 1, up 1 over 1. So where should it hit on the axis? I might have messed it up. How many times am I going to go up 1 over 1 before I hit this axis? 4 times. So where is it going to hit? 11. So did I draw it right? Yeah, so actually I was being kind of careful. So that was correct. Draw your stuff to scale, please, in this assignment, at least decently. Notice that's good enough. Okay? You have to be super neat and precise. But the main thing we're looking at here is how do we write down the function expression? G of x. What is this graph in terms of g of x? That's what I really want to know here. So, let's think about where we moved it. Do we move it up or down? Clearly we moved it down. Do we move it left or right?
Left.
Clearly we moved it left. At the top of your sheet, you'll see there's one tip to understanding transformations as a whole, everything, all at one time. 2 little sentences. If you understand those 2 little sentences well, you can forget about everything else on this sheet. I don't think according to this sheet at all. I just know those 2 sentences. I know them really, really well in any kind of situation, and I'll never mess up a transformation because of it. That can be you too, and it will be you if you work hard. Maybe it won't even be hard. What's the first sentence say? Can somebody read it for me?
Vertical transformations happen outside and generally do what you expect.
Okay, so vertical stuff, any kind of vertical stuff. If it's like a shift vertically, a stretch vertically, a flip vertically, that is going to be where in regard to whatever kind of function. It's going to be outside, okay? What about horizontal? Someone else take that one? You want to go, Grant?
Horizontal shifts primarily happen inside and do the exact opposite of what you expect.
Ah, okay, so horizontal happens inside. We've already seen that on a couple problems, right? Horizontal's always going to happen inside, whether it's a shift, a stretch, a compression, or a reflection. Horizontal's always on the inside. A shift is going to be like a subtraction or addition. A stretch is going to be a multiplication or division. And a flip is going to be insert a negative. And it's always going to be opposite of what you expect. Let's think about that. So, the outside one is going to be what on this? It's going to be down. Down how much? 15. So we'll get an absolute value going. We'll stick an x in there because that's the specific function we're working with this time. When we work with a new function, this is all going to work the exact same way. We'll just have a different kind of symbol there for a different function or a different shape. So, for us, I'm going to have a minus 15 or a plus 15. And where's it going to go? Did I go up or down? I went down. Is outside stuff, vertical stuff, what you expect or not? It's what you expect. So minus 15 or plus 15? Minus 15 should be what you expect for down, isn't it? Okay. So, we went left or right?
Left.
Left. We went left by 4?
Yes.
So, left goes inside or outside? Inside. Is it what you expect or not? It's the opposite. So you might expect it to be negative 4, but because negative 4 is that way, but it's opposite at positive 4. That's the graph. If you don't believe it, you can put it in your calculator. We're going to do that in just a second. In my second video, you'll see a lot of calculator demonstrations. Yeah, Fiona. And right was horizontal, so it's inside. I would think you should expect 8 to be plus, right? Isn't right 8 plus 8? So that's opposite. Good question. If you learned the last lesson pretty thoroughly, how do you read this? How did we read this yesterday?
G of x equals.
Here's a way to fit this together with everything else we know. Go ahead.
G of x equals the difference of x to 8.
The distance from x to 8. The thing here is though, oh, I see your mistake. I see my mistake, Fiona. What was Fiona talking about? Did I go right by 8? That's my mistake, my bad. I was too focused on talking. I should have been over here, shouldn't I? But it was still an 8 there. Thank you. That was the catch. Thanks, Fiona. I didn't notice my graph was on the wrong side. Anyway, so like Michael said, he said this says g of x is the distance from x to 8. 8 is over here, not over there, right? So how do you do this one the same way? This should fit together everything we know. Instead of saying plus, I could go x minus a -4, and then we'd read that as the distance between x, the x values on our curve, and -4. Well, that's why it's -4. So this all fits together. But I promise, if you start thinking about transformations in this inside is outside, or excuse me, vertical is outside and what you expect, horizontal is inside and the opposite of what you expect, they're all easy. That's all you have to learn for all of them, for all year. So you can use this cheat sheet as you like when you're getting started. If you start trying to think like that, you're going to master it very quickly. I hope you watch my second video where we look at some calculator work. There'll be a lot more examples there. See you next time.